Howdy, my name is Luca Lopez, and this is my litter survey presentation. So the first, these are the two locations that I chose. Seeing how close they are together, though, we could be seeing, my initial hypothesis is that we could be seeing very similar data, but with the survey location 2 having more metal content than 1 considering the industrialized area. The location 1 was a beachside off of the, right off of the bridge. You can see it coming in. I decided to do this one considering its openness to the bay and to the mainland and all the commercialized area. I thought I could find a good amount of plastics there. I chose this second survey location. Oh, the initial survey location had about 300 meters squared of area that I surveyed. The secondary location had a bit more area. It was this area right next to all of the ships and docks and industrialized area. I chose this location for two reasons. It's in the canal, and I wanted to see how trash was picked up based off of flow into a canal. And these are the results. As you can see on the beach side, the total amount that we had was about the main component was silicon, which was a lot of commercial items such as foam cups, lids, plastic bags. For the metals, we had iron bars, sheets of metal like signs, and then for carbon, we had many things like cigarettes, wood. With the canal location, we had an increase in the amount of silicon and in metal, but there was a significant decrease in carbon. The reason for the increase in metal is because it's near the vicinity of a bunch of industrialized area. When it comes to the litter total, there's more total, roughly around more total for the first location than it is for the second. The blue is the beach side, and the orange is the canal location. They're almost roughly the same, but there's a little bit more in the first location. But when it comes to the trash density, that's when there's a huge difference. The beach side has almost double the amount of trash density than the canal side does. And I believe that this is due to its more openness to the bay, and there's more water that can go into it. For the components, I chose things like a metal sign. The main two things about a metal sign is that it has a aluminum, it's what it's made out of, and the plastic coating to prevent rusting or reactions. And based off of how well the plastic coating is still on, can determine how long it could actually stay there. For carbon, I choose cigarettes, which has nicotine and hydrogen cyanide in it, which can pollute and poison the water. For silicon, I had foam cups, which are filled with many different types of plastics, which can break down into microplastics and affect wildlife. So the questions for the questions number one, what is the estimated turnover time in the environment? For the cigarettes, it'll take up to 10 years to decay. The aluminum can last for about 10 years, but also depending on the thickness and the coating of the plastic. The foam cup can become microparticles and last for almost 1,000 years, while the plastic lids will last about like 500 years. For question number two, they are not equally degradable. So the carbon degrades faster than the plastics and the aluminum and the foam, but all of them take a good amount of time and will affect greatly in the short term. For number three, what are the short-term and long-term effects of chemicals listed and ingredients in the environments? The short-term effects of these items is that they could actually produce toxic waste for the waters, which can damage the fish, the wildlife's health, and they can also contaminate the fresh water with the metals, and they could kill nearby wildlife. And these are my sources, which I got all of my scholarly data.